Okay, thank you. Welcome for our lesson today. I'm Mr. Omar. I want to proceed from where I left yesterday. You remember that we were talking about two forms of energy, where I said that there are a type of energy where is energy in motion. I said it is known as kinetic energy, and we also have energy at rest, which we said is known as potential energy. Now, to narrow down today, I want to proceed by talking about types of energy, of which we have 6 main types of energy, and we will have to narrow down and discuss each and every type of energy specifically. Now, straight away, I will start discussing about chemical energy, of which I have highlighted all the 6 types of energy here. We have chemical energy, we have heat energy, we have light energy, we have magnetic energy, sound energy, and electricity as also the 6th type of energy. I said chemical energy is also known as stored energy. As I talked about the 2 forms of energy, chemical energy was one part of stored energy, of which I said is also known as potential energy. It is found in substances like foods, fuels like firewood, charcoal, and also kerosene. So when we talk of chemical energy, what are some of these sources where we can get chemical energy? I say we can get chemical energy from foods we eat, we get it from fuels like firewood, charcoal, and also kerosene. Now, when we talk of foods, how are we getting the chemical energy from foods? We get chemical energy when you consume food. It goes to the alimentary canal, then as it is digested and absorbed in the small intestine, and then it goes to the body as chemical energy. Now that person gains energy from that food. They say energy is released when fuel is burned. The type of fuel we are talking about: firewood, charcoal, and kerosene. So when you burn them, you find that after being burnt, they produce heat energy. That one is so the whatever is having chemical energy are the fuel, which is firewood, charcoal, and also kerosene. Chemical energy stored in our bodies is further broken down to give out heat energy. So you find that the body is kept warm because we are consuming different types of food. So after the food has been digested in the gut or in the small intestine, you find that the body is warmed by the energy from the foods. Now, suppose somebody is eating a lot of food. You find that this a lot of food, excess food somebody eats, produces a lot of energy in the body, and the whole of energy cannot be used up. You find that excess energy that has been produced by the person who has consumed a lot of food is stored in the skin in the form of fats. So when you consume a lot of food, the whole energy is not used up. You find that the excess energy is stored in the body for future use. You find you have consumed food today, and that energy can be stored in the body in the form of fats to be used next week. So a lot of energy is stored in the body in form of fats. Last point: dry cells and car batteries. Without forgetting, dry cells and car batteries also have stored energy. So we have talked about food and fuels. Food and fuels as the types of items that are having chemical energy. So to add on foods and fuels, we also have dry cells and car batteries as also other forms of chemical energy. Now we have now discussed chemical energy. Now we come to heat energy. The second type of energy is heat energy. Heat energy. Heat energy, this one is not the first time you are talking about heat energy. In your previous classes also you discuss about heat energy. There are sources of heat energy, there are functions of heat energy. Now, when you talk of heat energy, what is the main source of heat on the earth? We find that the main source of heat is the sun. Let me write the heading: heat energy. You find that the main source of heat energy is the sun. Now, the main source, there are other sources of heat, but the main source is the sun. So you have to highlight that. And then other sources, let us talk about other sources of heat. We have electricity, other sources of heat energy. Other sources of heat energy. What are these other sources of heat energy? One, we say the other source of heat energy, we talk about things like electricity, burning fuels. Electricity is also another source of heat. Number two, we have fuels, burning fuels like charcoal, kerosene, and charcoal, kerosene, and firewood. These are also other sources of heat energy. Now, when you talk of the sun, this is just the main source of heat energy, but other sources of heat energy, you can get heat from the electricity. Fuels like charcoal, kerosene, and also firewood are other sources of heat energy. Now, what are the uses? In your previous classes, you discussed about the uses of heat energy. Very important. What are some of the uses when we are producing this heat? Why are we producing it? Now, these are the uses of heat energy. Uses of heat energy. Number one, they are common for warming ourselves. It is used for warming ourselves. Number two is used for ironing clothes. Number three, it is used for drying cereals or grains, drying. Number four, heat is used for cooking. Heat energy is very important in our daily lives because it is serving these purposes and also others. But when you are asked what are the main function of heat energy, you have to talk about warming. When the weather is very cold, you find that you might start shivering. So you have to go where there is a source of heat to warm your body. So warming is the function of heat. Ironing our clothes for you to be to look official and smart, you have to iron your shirts and also other clothes. So ironing is used by an iron box, and it is having heat. That heat is the one that is making clothes smart. Now we have number three, drying of cereals. All the grains before they are stored, maize, beans, green grams, all the grains before they are stored. We were talking about food and nutrition last week. So we said they are supposed to be dried properly before they are stored. So drying is applied by heat. Now lastly, we also have cooking. Almost 99% of food are cooked before they are consumed. So cooking, for you to cook the food, you must have heat. You cannot cook food without heat. So these are some of the functions of heat. Now, we also talk about heat transfer. Heat transfer. Heat transfer. Heat transfer. What do we mean by heat transfer? You find that heat can be transferred from one region to another, or from one place to another. So how is heat transferred? Heat is transferred because of difference in temperature. You find that if there is a place that is having a lot of temperature, heat will move from that place to the place which is cooler. So, or if it is along an object, we have to talk about heat transfer. So I said, due to difference in temperatures, we will have heat transfer due to differences heat is caused due to temperature differences. You find that heat transfer is caused. Now, how is heat transferred? There are three main ways in which heat is transferred. There are three main ways in which heat is transferred. One, we talk of conduction. Heat can be transferred in a form of conduction. Heat can be transferred in a form of convection. And lastly, it can be transferred in a form of radiation. These are the three main forms in which heat is transferred, and I'm very aware that this is not your first time to hear about conduction, convection, radiation. This is a part which is examination fertile area. Many of the questions are coming from conduction, convection, and radiation, and that is a form of heat transfer. Now, when we narrow down, we talk about conduction, convection, and radiation. How can we define it? We say that conduction is a process where heat is transferred in solids. Where heat is transferred in solids, that is what we call conduction. Convection is a process where heat is transferred in liquids or in gases. And lastly, radiation is a form of heat transfer where heat is transferred in is a way the heat from the sun mainly reaches the earth or us by radiation. Why? Because when there is heat moving from the top to bottom, that one there is no air. So the main form in which is, the heat from the sun reaches us is by radiation. Or when we have movement, horizontal movement of heat moving horizontally, that one is also radiation. But now when heat moves from bottom to top, that one is convection, because there is movement of air. When air from the bottom is heated, it becomes less strength and then it rises with that heat, and that is what we call convection. So radiation is only when heat moves from the top to the bottom or horizontally from side to side. That one is radiation. So you have to know that difference. Now, we have convection. Convection, I said there are two ways: movement of heat in liquids and also movement of heat in air. Now, I've said upright from bottom to top is convection. Now we also have convection current. For example, if we perform a such experiment, then here is clear water, and you drop here the ash or the sand, you will find that it will form convection current. Here is water, and then you are heating. You apply heat. When you apply heat and there is clear water here, you will find that sand particles will start moving, forming circular movement like that. So why? Because when you start heating at the bottom here, the sulfur becomes hot, it heats water which is immediately to the surface, it becomes less tense, then it moves up as the water from the top, which is cold, then moves downward, and then it forms what we call convectional current. That is what we call convection in liquid. And then lastly, conduction, we have movement of heat in metals or in solids. For example, you can have this experiment which is very common. This one is metallic rod. And then we have the pins. These are pins. fixed on the metallic rods with wax. Then you have the source of heat. This one will mean that the moment you start heating the metallic rod here, it becomes hot. Then that heat is transferred from here, this first point, towards the other end. Now, that is why when you are asked, this is pin A, pin B, pin C, pin D. You are asked which pin will be the first to drop. You find that this pin which is next to the source of heat will be the first one to drop down. Why? Because heat is here and then it is moving from this point towards the other end. The pin B will fall down the second as you proceed. The last pin to drop will be pin D. Now, that is an experiment of conduction, heat movement in metallic. Then we also have another experiment. If they fix pins like that, now here instead of saying it is a metallic rod, they say it is wood. Now this is another experiment. When you are asked which pin will be the first one to drop, you understand wood, rubber, chokes are poor conductors of heat. There will be no conduction. Why? Because heat is not moving in wood, so no pin will fall down. This is also another experiment. You have to know how to explain it when it is metallic and also when it is wood. Now, investigating, we can also have an experiment to investigate the rate of conduction in different metals. An experiment to demonstrate different rates, different rate in conduction. Different rates in conduction. Different rates in conduction. Okay. Different rates, you find that there are different materials, different metallic materials. So you will find that there is a metal which is conducting heat faster than the other one. If you perform an experiment and then you start heating those metals at the same time, you will find that they are conducting heat differently. So an experiment like this, then I have my source of heat here. This one is a source of heat. All the metals are of the same length, and then they are fixed there at the same time. And then we have to know which metal is conducting faster than the other one. This one we want to know which rate. We can take, for example, this metal is steel, this one is aluminium, this one is iron, and this one is copper. Iron, and this one is copper. Then you fix at the end here a pin with wax. Fix here a pin at the end with wax. Fix a pin with wax, and also fix here a pin with wax. Then start heating at the same time. You will find that all these metals, because they are different, we have steel, we have aluminium, we have copper, and we have iron. All the pins will not drop at the same time. There is a metal which is conducting faster than the other one. So you will have to see which metal is conducting fast. Now, the best conductor of heat is silver. Silver is always the best conductor of heat, followed by copper, followed by aluminium, followed by steel, and then we have iron. From the top to the bottom, you will find that if you have performed this experiment, for example, in our experiment here, we don't have silver here. But if we had silver, the pin from that silver will have dropped faster than the other metals. But we have copper here. Now in our experiment, the pin that is attached to copper metal will drop fast. Then we will have followed by aluminium, then followed by steel, then the pin from the iron will take a little bit longer time. Why? Because when it comes to red, all of them are conducting, but reds, one metal is conducting faster than the other one. So we have silver being the best conductor, followed by copper, aluminium, steel, and lastly we have iron. Now, when you are performing this experiment, what are the controlled variables? Controlled variables in this experiment that can lead to wrong results. Controlled variables can lead to wrong results. Controlled variables. This question is also common. You find that after performing an experiment, you are not coming out with the correct observation. Why? Because you have missed in one or two things. You make sure that the thickness of the rods is the same. Thickness of the rods. You find that if one rod is thicker than the other one, so it is having a larger surface area. So for all the particles to have heat, it will take longer. So make sure that the thickness of the rods is the same size. It is having the same thickness. Then second, we have distance or length where the pins are attached. Distance also matters. We have the source of heat here. And then we have two metals. Then you are performing conduction. This is source of heat. And then you fix here the first pin here, and then the second pin here. For example, here is 30 centimeters away from the source of heat, and here is 10 centimeters away from the source of heat. You find that distance also matters. Make sure that when you are performing the experiment, the distance from where you are fixing the pins and the source of heat is the same. So distance matters. And then we also have amount of wax. We have amount to mean the amount of wax fixed should be of the same size. Don't use a lot of wax on one variable and also use less wax on the other metal. Then we have the source of heat. If you are using a candle, you just use a candle. Don't use one experiment candle, another one you are using electricity. You find that amount of heat is different from different sources, so make sure it is the same amount. And then we also have type of conductor. So you might use a poor conductor, and also you can use a good conductor of heat. So you find that there are also uses of poor conductors. We said good conductors, they have a lot of functions, they have their importance. Then we also have poor conductors. What are some examples of poor conductors of heat? Poor conductors of heat, we have number 1, wood. We have number 2, rubber. Materials like chalk. We have such a materials are poor conductors. Now, they does not conduct. So what are their function? You find that they are known as insulators. These are insulators. Insulators. They are used to form the handles of cooking pans and also cooking stick. When you are cooking, make sure the insulators, wood, rubber, and materials that are made from chalk can be used at the end of the handles to make sure that heat, when you are frying maybe meat, heat from the frying pan is not reaching your hand. So they are used to make insulators. Now, that is heat. Next, we have to discuss about light as we continue discussing of all the 6 types of energy. Now, I call the end of our lesson today. Thank you very much.